Popular histories of quantum mechanics generally award a central role to the so-called ultraviolet catastrophe. Physicists at the end of the 19th century realized classical physics predicts that electromagnetic energy radiated by a black body, which we can envisage as a warm, totally light-absorbing object, becomes infinite for wavelengths shorter than those of visible light in the ultraviolet part of the spectrum. This was obviously wrong, and in 1900, Max Planck found he could avoid the catastrophe by assuming that the oscillating atoms in the black body could only emit energy in discrete packets, quanta, or a size proportional to their vibration frequency. He denoted the constant of proportionality as h, now called Planck's constant. Exactly how Planck viewed his quanta is still disputed, but he seems to have resisted for years the idea that they corresponded to reality, seeing them instead as a mathematical convenience. The hypothesis proposed by Planck that energy is quantized or divided into chunks avoided the ultraviolet catastrophe predicted by classical physics for black body radiation. A perfect black body seems an oddly exotic entity, but it really is just an idealization of a warm body. The basic idea that the hotter the body is, the more short wavelength radiation it emits, and is comparable to the glow of an electric bar heater as it warms, and applies to stars too. Even black holes emit black body radiation in the form of Hawking radiation. Hawking radiation occurs when virtual particles briefly appear and disappear into space. Usually, they leave no trace, but this happens near a black hole's event horizon. One particle can be pulled into the hole while the others fly off, creating radiation. The black hole acts rather like a black body with a temperature inversely proportional to its mass. Physicists resolved the ultraviolet catastrophe by imposing restrictions on the way a black body atom can oscillate at a high frequency and thereby reducing the energy they radiate, was only pointed out later. Still, the idea won Max Planck a Nobel Prize in 1918.